Just 100 years ago, if a child was diagnosed with diabetes, doctors could do almost nothing to save them. Parents were told to feed their children less and less food while they slowly faded away. Many children starved to death before the disease itself could take them. Then in 1921, a small group of researchers made a discovery that would change medicine forever. A hormone hidden inside the pancreas that could unlock the body's ability to use sugar. Today, that discovery keeps more than 400 million people alive every single day. But the story of how insulin was discovered is far more dramatic than most people realize. Because it began with desperate experiments, dying patients, and a race against time to save lives. Please like, subscribe, turn on notifications, and comment the next video topic in the comments. Imagine sitting in a doctor's office in the year 1920. The doctor finishes examining your child. He looks concerned but calm. Then he tells you something that changes everything. Your child has diabetes. Today, that diagnosis would begin a treatment plan. Doctors would talk about insulin therapy, blood sugar monitoring, and long-term management. Millions of people live long and active lives with diabetes today. But in 1920, those words meant something very different. They meant there was almost nothing medicine could do. In fact, for most families at that time, the diagnosis meant that death was coming, often very soon. Parents watched their children become constantly thirsty. They drank water all day and still felt dehydrated. They were hungry all the time, but strangely kept losing weight. At first, the changes seemed confusing. Then they became frightening. The child who once ran and played outside now seemed tired all the time. Their clothes began hanging loosely from their bodies as the weight continued to fall away. Doctors could measure sugar in the urine and see that something inside the body had gone terribly wrong. But they had no medicine to fix it. Instead, they gave families a devastating instruction. Feed the child as little as possible. To understand why doctors made such a harsh recommendation, we need to understand what diabetes actually does inside the body. Because the disease was slowly starving patients even when they were eating. And solving that mystery would eventually lead to one of the greatest medical discoveries in history. But before that breakthrough arrived, the world had to endure one of the darkest periods in medical treatment. A period doctors later called the starvation era. And the reality of that era was far more brutal than most people today realize. The next part of the story begins long before insulin was discovered, when doctors were still trying to understand why sugar seemed to flood the bodies of diabetic patients without ever reaching the cells that needed it. For centuries, diabetes was a mystery. Doctors knew the symptoms. Patients became extremely thirsty. They urinated frequently. They lost weight rapidly. Their bodies weakened over time. But the true cause remained hidden. One strange clue kept appearing again and again. Sugar was leaving the body through urine. Doctors discovered that the urine of diabetic patients contained large amounts of sugar. At a time when laboratory equipment was primitive, physicians used creative methods to confirm this observation. What they discovered puzzled them. The body seemed to be producing or releasing sugar in massive quantities, yet the patient looked as though they were starving. Something was preventing the body from using its own fuel. Eventually, researchers began focusing on a small organ located behind the stomach, the pancreas. Experiments with animals revealed something important. When the pancreas was removed from a dog, the animal developed symptoms almost identical to diabetes. This suggested that the pancreas produced a substance that helped regulate sugar in the blood. If that substance disappeared, diabetes appeared. It was an exciting clue, but it created a new problem. Scientists could not isolate the mysterious substance. The pancreas contains powerful digestive enzymes designed to break down food. Those enzymes destroyed delicate biological compounds almost instantly. Every time researchers attempted to extract the substance they believed controlled blood sugar, it was destroyed before they could study it. So the mystery remained unsolved. Meanwhile, patients continued to die. Doctors were left with only one strategy that seemed to slow the disease, even if only slightly. Reduce food intake to extreme levels. And this desperate strategy soon became the most common treatment for diabetes. The logic behind the starvation treatment was simple. Doctors knew that eating carbohydrates increased blood sugar levels. Since diabetic patients already had dangerously high sugar levels, reducing food intake seemed like the only way to control the problem. But the solution came with a terrible cost. Patients were placed on diets so restrictive that survival itself became uncertain. Some treatment plans limited daily food intake to only a few hundred calories. In certain cases, patients were given as little as 450 calories per day. To put that into perspective, most healthy adults need several times that amount just to maintain basic body functions. Even children were forced to follow these diets. Meals became painfully small. A few vegetables, a small portion of broth, sometimes tiny amounts of protein. Bread was removed completely. Sugar was forbidden. Many fruits disappeared from the menu. Hunger became constant. Patients described feeling dizzy, weak, and exhausted nearly all the time. Walking across a room could feel like climbing a mountain. Doctors closely monitored these patients because the goal was to balance two dangers at once. Too much food could accelerate the disease. Too little food could lead to starvation. Families faced heartbreaking decisions every day. They watched their children grow thinner and weaker as the diet continued. Many patients became skeletal. Their cheeks sank inward. Their ribs became visible beneath their skin. Their muscles shrank as the body consumed itself for energy. And even when the diet slowed the disease for a short time, the final outcome was usually the same. Eventually, the body reached its limit. Without the ability to properly use sugar for energy, the body began burning fat at an extreme rate. This process created acidic chemicals called ketones. When ketones accumulated in the bloodstream, the body entered a dangerous condition known today as diabetic ketoacidosis. Breathing became deep and rapid. Confusion appeared. Weakness became overwhelming. Without treatment, coma soon followed. Then death. Doctors documented these tragic cases carefully, but their medical notes often ended the same way. There was nothing more they could do. Yet at the same time this tragedy was unfolding in hospitals around the world, a young surgeon in Canada was beginning to think about diabetes in a new way. He believed the mysterious substance hidden inside the pancreas might still be discovered, and that idea would soon change the fate of millions of people. Frederick Banting was not a famous scientist when he began thinking about diabetes. He was a young Canadian surgeon trying to build his career. He had served as a medical officer during the First World War and later began studying medical research in his spare time. One night, while reading about the pancreas, Banting noticed something that sparked his curiosity. The pancreas contains tiny clusters of cells known as the islets. These cells appeared different from the rest of the organ. While most of the pancreas produced digestive enzymes, the islet cells seemed to release hormones directly into the bloodstream. Banting wondered if these cells produced the substance that controlled blood sugar. If that were true, the challenge would be isolating that substance without allowing the digestive enzymes of the pancreas to destroy it. Then Banting imagined a possible solution. What if the digestive portion of the pancreas could be disabled while leaving the islet cells alive? Without digestive enzymes interfering, the hormone might survive long enough to be extracted. It was a bold idea. Many scientists might have dismissed it immediately, but Banting believed it was worth trying. To test the idea, he needed a laboratory, research animals, and someone willing to give him a chance. That opportunity came from a professor at the University of Toronto, and that meeting would soon begin one of the most important medical experiments of the 20th century. In 1921, Banting approached Professor John MacLeod at the University of Toronto. MacLeod was an experienced scientist who had spent years studying metabolism and diabetes. At first, he was skeptical of Banting's proposal. Many researchers had already attempted to isolate the anti-diabetes hormone and failed. But Banting was persistent. Eventually, MacLeod agreed to provide laboratory space during the summer months and assigned a medical student to assist him. That student was Charles Best. Together, Banting and Best began a series of difficult experiments using dogs. Their goal was to isolate the substance produced by the pancreatic islet cells. The work was challenging and often frustrating. Surgical procedures had to be performed with precision. Blood sugar levels had to be measured repeatedly. Many early experiments produced confusing results. But after months of persistence, something remarkable happened. An extract prepared from pancreatic tissue was injected into a diabetic dog. Soon afterward, the dog's blood sugar began to fall. Even more surprising, the animal's condition improved. It regained energy. It began eating normally again. The experiment suggested that Banting and Best had successfully isolated the hormone responsible for controlling blood sugar. At first, they called it Insulin. Later, it would become known by a different name, insulin. But before this discovery could save human lives, another challenge had to be solved. The extract needed to be purified, because in its early form, it was not yet safe for human patients. And the person who would solve that problem would soon join the research team. His work would make the first human treatment possible. By the time Frederick Banting and Charles Best proved that their pancreatic extract could lower blood sugar in diabetic animals, excitement inside the laboratory was growing. They had discovered something real. The extract clearly affected blood sugar levels. The diabetic dogs that received it showed remarkable improvement. Animals that would normally grow weak and die from uncontrolled diabetes suddenly regained energy. But there was still a huge problem. The extract was crude. It contained many unwanted biological materials from the pancreas. When injected, these impurities could cause dangerous reactions. The mixture was unstable and inconsistent. One batch might work better than the next. Another batch might cause severe side effects. If this discovery was ever going to help human patients, the extract had to be purified. That challenge required a different kind of expertise. This is where a biochemist named James Collip entered the story. Collip joined the research team with a clear mission. His job was to transform the crude pancreatic extract into something that could be safely injected into people. This was not simple work. The hormone they were trying to isolate was extremely delicate. If the purification process was too aggressive, the hormone would be destroyed. If the process was too gentle, dangerous impurities would remain. Collip worked long hours experimenting with different chemical methods to separate the active hormone from the rest of the pancreatic material. Day after day, he refined the process. The pressure inside the laboratory was intense. Hospitals were filled with patients slowly dying from diabetes. Families were desperate for hope. If the team succeeded, the treatment could save lives immediately. After weeks of careful work, Collip finally produced a much cleaner version of the pancreatic extract. Now the team faced a moment that would change medical history. They were ready to try the treatment in a human patient. In January 1922, a 14-year-old boy lay in a hospital bed in Toronto. His name was Leonard Thompson. Leonard had been living with severe diabetes for months. Like many patients at the time, he had been placed on a strict starvation diet in an attempt to slow the disease. The diet had kept him alive for a short time, but it came at a terrible cost. He was extremely thin and weak. His body had lost most of its strength. Doctors knew that without a new treatment, he would not survive much longer. Leonard became the first human patient chosen to receive the experimental pancreatic extract. The room was filled with cautious hope. Banting, Best, MacLeod, and Collip all understood the importance of this moment. If the injection worked, it could prove that insulin was a real medical treatment. If it failed, the dream of curing diabetes might collapse. The first injection was given carefully. At first, the results were disappointing. Leonard's blood sugar levels dropped slightly, but the extract still contained impurities that caused an unwanted reaction. The team realized the purification process needed to improve even further. Collip returned to the laboratory immediately and refined the extract again. Soon they were ready for a second attempt. When Leonard received the improved injection, the results were dramatic. His blood sugar dropped significantly. His symptoms began to improve. The change was not temporary. Over the following days, his strength slowly returned. His appetite improved. The constant weakness began to fade. For the first time in medical history, a patient with severe diabetes was not dying. He was recovering. Insulin had just saved its first human life. News of the successful treatment spread rapidly through the medical community. Doctors who had spent years watching patients die from diabetes suddenly had a new tool. Hospitals began requesting insulin for their own patients. Laboratories rushed to produce larger quantities of the hormone. Within a short time, insulin therapy began spreading across North America and Europe. The transformation inside hospital wards was astonishing. Children who had arrived weak and skeletal under starvation diets began gaining strength again. Their weight returned. Their energy returned. Families who had prepared for the worst suddenly saw their children recovering. Doctors who had once felt helpless now had the power to save lives. The discovery of insulin quickly became one of the most celebrated breakthroughs in medical history. But even as insulin began saving lives, scientists were still learning exactly how it worked inside the body. Understanding that process would reveal just how important this tiny hormone truly is. To understand insulin, imagine every cell in the body as a small locked room. Inside that room is the machinery that produces energy. But for the machinery to work, it needs fuel. That fuel is glucose. Glucose is a type of sugar that comes from the food we eat. When carbohydrates are digested, they break down into glucose molecules that enter the bloodstream. The bloodstream carries glucose throughout the body, delivering energy to billions of cells. But there is a problem. Glucose cannot enter most cells by itself. The cell membrane acts like a locked door. This is where insulin plays its crucial role. Insulin acts like a key. When insulin attaches to specific receptors on the surface of a cell, it unlocks the door and allows glucose to move inside. Once inside, the cell can use that glucose to produce energy. Without insulin, the doors remain closed. Glucose builds up in the bloodstream while the cells remain starved for energy. This explains why diabetic patients before insulin therapy seem to be starving even while eating large amounts of food. Their bodies had plenty of fuel, but they had no key to unlock it. Insulin provided that missing key. With insulin therapy, glucose could once again enter cells and power the body's systems. Energy returned. Strength returned. Life returned. More than a century has passed since the first insulin injection saved Leonard Thompson's life. During that time, insulin therapy has continued to evolve. Early insulin treatments required multiple injections using crude equipment and animal-derived insulin. Today, modern insulin is produced through advanced biotechnology. Scientists use genetically engineered bacteria to produce insulin that is nearly identical to the hormone naturally made by the human body. Different forms of insulin now exist for different purposes. Some types act quickly to control blood sugar after meals. Other types act slowly to maintain stable levels throughout the day and night. Medical technology has also advanced dramatically. Many people now use insulin pumps that deliver precise doses automatically. Continuous glucose monitors track blood sugar levels in real time and send data directly to smartphones. These tools allow individuals with diabetes to manage their condition with far greater accuracy than ever before. Millions of people with diabetes live full and active lives. They attend school, build careers, play sports, travel, raise families. The disease that once guaranteed an early death has become a manageable chronic condition. And all of it began with a discovery made in a small laboratory in 1921. The story of insulin is more than a scientific breakthrough. It is a reminder of how persistence, curiosity, and courage can change the future of medicine. Before insulin, diabetes meant death. Today, insulin gives life to hundreds of millions of people every single day. And the question that remains is this: what other diseases that seem impossible to cure today might someday be transformed by the next great discovery waiting to happen? Don't forget to subscribe on your way out. See you next video.